And so we're ready to get started. So Andrew is going to be giving us the keynote today. He's a senior research methodologist at Pew Research Center, and he was at Westat before he joined Pew. He's an expert on probability-based online panels, non-probability survey methods, and survey non-response. I met Andrew several years ago now when we and some other folks that are here, including Jenny and Cameron, served on APOR's task force on data quality metrics for online samples. The task force was chaired by Cameron and featured some particularly heavy lifting by Andrew. So I was really impressed at the get-go. In addition to the task force report, Andrew's authored blog posts and analyses making methodological concepts such as margin of error and oversampling accessible to a general audience. His research has been published in Public Opinion Quarterly in the Journal of Survey Statistics and Methodology. And a few months ago, as all of us know, or at least most of us probably, I published a Pew study comparing opt-in and probability-based panels. His findings and his background made him a terrific fit for CIPHER, so we were really very excited when he accepted our invitation to give the keynote this year. So I will go ahead and turn the podium over to Andrew, who has kindly agreed to spend some time talking while the rest of us eat lunch. As you can see, his talk is titled From Buggy Whips to Bogus Respondents, Changing Perspectives on Data Quality in Online Surveys. I'm hoping that he will give us a little dance recital here when he's done. Thanks, Andrew.
Thank you, Jill, for that introduction. I feel like I should toast the happy couple or something like that. But big thank you to Ari and everybody else who organized this. This has been a phenomenal conference. This is the first time I've been able to attend in person. And this year I was racking my brain to come up with an abstract to submit when I got the email from Jill inviting me to give this talk, which saved me quite a bit of effort on that front. So thank you. The talks have all been terrific. And I think actually there were a lot of instances over the last couple of days where I wanted to jump in and have a comment, or I had to save my material for this because there's so many themes, I think, that are recurring that kept coming up that I'm going to be talking about today. The other thing is all the work that I'm talking about is not just me, but also the fabulous methods team at Pew Research Center, particularly Arnold Lau, who's my co-author on the recent benchmarking study that Jill mentioned, and Courtney Kennedy, who leads our efforts over there. So let's see, there we go. So the title, let me go back, the title, there we go, From Buggy Whips to Bogus Respondents, when we were sort of workshopping this on the Pew Methods team, is one is we realized a lot of people don't know what a buggy whip is. So this is this is back in the day when you had a horse and buggy and you needed to whip the horse to get it to go. So we've got that out of the way. The other thing is that a lot of people may not know the reference when it comes to probability-based samples. And I don't know, is Mike Link here? He definitely does. So some history. It turns out this was almost exactly 10 years ago, and I thought it was a nice way to set things off. So back in 2014, the New York Times ran an article, Young Undocumented Immigrants Growing Disenfranchised with Both Parties Study Finds. And this was controversial because previously the New York Times had a policy of not reporting on opt-in samples. So it had to be a probability-based sample. APOR responded to this with criticism about having, relaxed their standards and problems with sort of a lack of theory that underpins a lot of the non-probability methods. That in turn prompted a reply from Andrew Gelman, who's a famous statistician at Columbia, saying that the president of the American Association of Buggy Whip Manufacturers takes a strong stand against the internal combustion engine, suggesting that sort of the non-probability samples are sort of the future, and that a lot of the people sort of clinging to probability-based methods, design-based inference, were sort of stuck in the past. And his sort of argument it was the foundation for what a lot of people say is, there's no such thing as a probability-based sample when you have such high non-response rates. I'll confess, I subscribed to that view at one point. And I think there's actually still a certain amount of truth to it, but we're sort of missing the point, and I will get back to that. So where are we now? That's sort of the state of the argument 10 years ago. There was actually, a lot of bitter back and forth on all sides of this. If we look at the state of things today, online opt-in is now the most common method for election polling, horse race polling. So this is from a report that we put out, Courtney Kennedy led, counting the number of pollsters since 2000 in every election cycle who use various methods, right? And so here on the left, we've got and this is the number of pollsters, not the number of polls or a percentage, but 22 pollsters in 2022 using, live phone alone or in combination with other methods. 46 are using online opt-in now, right? And up to 23 are using probability-based online panels. So we see a big increase in the probability-based panels that we've been talking about here, but much bigger growth in the opt-in. And if you count number of polls, just because of the cost factor, it's sort of the opt-in dwarfs all the other methods. Now, the APOR code includes references and guidance for non-probability methods. And there's a recognition that even probability samples need models. So this is from the task force report that Jill and I worked on that she mentioned. And, here it says, the assumptions of design-based approach often do not hold for data collected from online samples. And that, even for panels that rely on probability-based recruitment methods, there may be substantial deviations from random sampling that, threaten our ability to make inferences based on that randomization. So on top of that, 10 years later, Andrew Gelman is the recipient of the Warren Matofsky Innovators Award for his work on MRP. And so you would be, if this was sort of all you were seeing, you would be forgiven for thinking that this question is sort of settled of online, probability-based samples, non-probability-based samples, and the sort of data quality concerns that people raised early on have more or less been sorted out. So is that really true? What about data quality? Have those data quality issues been dealt with? So this is the 2016 Pew Research benchmarking study. As you saw today, there are many like it, but this one is mine. I think John Krosnick has been involved in many, if not most, of these similar kinds of studies. But so we did this in 2016 when we were trying to figure out how the center was going to continue to do high quality research into the future. And so what we did was we compared benchmark estimates, 20 benchmark estimates on our American Trends panel. That's the row labeled ATP, and then 9 other online opt-in samples from a variety of providers. And this was not great. So what we found was on all of the benchmarks, on average, the ATP had about 8 percentage points of error on average. So this is average absolute error on a particular benchmark estimate. There were 4 opt-in samples that were more accurate on average, and a bunch that were less accurate. But we went into this study fully expecting that we were going to be sort of at the top of the list, and that this wasn't going to be such an issue. What we found was the probability-based sample, when we look at just 8 benchmarks that are related to civic engagement. I apologize, I can't actually point to this, but that second column, right? The American Trends panel had, substantial error on these benchmarks related to civic engagement. Those are things like talking to neighbors, volunteerism, that sort of thing. On benchmarks that were not related to civic engagement, that's that third column, right? The ATP was at the very top, right? So what that said to us is that civic, we are overrepresenting volunteers and the kinds of people who like to take surveys, right? What we also saw in that last column there is also that the American Trends Panel was almost the most accurate when it came to estimates among Black and Hispanic adults, right? And that was a particular area where the opt-in samples had a problem. So since then, a lot's changed, right? On our end, we've changed a lot about how we do the ATP, how it's recruited, how it's weighted, just tons of changes, right? The probability-based panel space has grown. There are now more commercially available panel providers. And the opt-in space has changed. There have been a ton of developments there. Routers and aggregators, like for instance, Scent and Lucid, those did not exist back at the time, or they were not as prevalent, I think, as they are now. And then also since then, we've had 2 large polling failures in presidential elections, right? And so what we wanted to do was update our 2016 study to see what things looked like today. So a couple of things that we did. We got 6 online samples, all from different providers. And importantly, we got 3 different probability-based panels and 3 different online opt-in samples. Because one thing that has not really been done before, or at least that I could find anywhere in the published literature, is direct comparisons of different online probability-based panels to each other. It's always been one probability-based panel and 15 different opt-in samples. And a part of that's just cost. And we were lucky that we were able to get the support to do that. We asked 15-minute questionnaire. We've got 28 benchmark questions. We used our sort of standard American Trends Panel weighting scheme on all of these. And importantly, we tried to get a sample size of 5,000 completes from each of these so that we would have a large enough sample to get a good look at data quality among subgroups, demographic subgroups. So what do we find? So this is what we found. So this is probably not a surprise to a lot of people who've been following this literature. What these bars are showing is the average absolute error on 28 benchmarks that were for general population estimates. And so the average across all 3 online opt-in samples up at the very top, 5.8 percentage points, right? The average error on the probability samples was about half that. So that was sort of heartening. I should say that, the comparability in these average estimates depends a lot on the specific benchmarks that are chosen. And so I wouldn't read too much into any absolute differences between these numbers and the ones on the previous slide. But this is consistent with most of the findings, with the exception of our study that found that, you do get better data from probability-based samples. And below this, you can see that the pattern, the levels were consistent across the 3 opt-in samples and across the 3 probability-based samples. We looked at the distribution of error on individual variables, and that's what this plot shows. One thing to make clear, what we did in this study is a little different from a lot of other benchmarking studies. The average error for a specific variable is not the error for a particular estimate. What we did is for variables that have more than 2 categories, we calculated the error for each of those categories and averaged them at the variable level, right? So we're not just picking the modal category or the category that I thought was most interesting or important. We're trying to capture it across the whole variable. So that's what we did. I will tell you, this makes this orders of magnitude more complicated to write about, talk about, and do, but I'm happy with the fact that we did it. And so these top panels here, these are each box here in these little histograms is one variable, right? And the x-axis is the error on that variable. And what we can see is on the probability-based panels, most of the error is bunched up close to zero, right? Which is what we'd expect to see. And that's what we want. Now, this is more error than you would get from just sampling error, right? But it's pretty consistent. And none of them had anything that had more than 10 points of error on average at the variable level. Below that, on the opt-in samples, there's really a lot more variability in terms of how much error we saw and how concentrated it was. We don't really see the same kind of concentration close to zero. We see, errors, some of them, well over 15 percentage points. So a lot more variability. There's a lot going on in this graph. So this is all of the individual benchmarks that we looked at. This is the average error for the benchmark. The orange dots are the average error for each probability-based panel on that benchmark. Blue is the opt-in samples. The only thing I really want to point out in this graph, right, is that you can see there's coherence here, right? The probability-based panels tended to do well or poorly on the same sets of variables, right? And the same is true for the opt-in samples, right? That there are two sort of clear different sets of different data generating mechanisms here that are related to one another. The other thing to point out, right, is this benchmark here where all three probability-based samples are still, this is the highest error on all of them. And that is the benchmark for having voted in the 2020 presidential election, right? So all three way overestimated voter turnout. And that suggests that we've still got this problem with civic engagement that we're continuing to work on. But so that's still a thing for probability-based samples. So those were Gen Pop estimates. That's not the interesting part of this report. The big story really was what happens in subgroups. And so here, if we look at that same graph, and now we're just averaging across all of the probability and opt-in panels. This is the average error on 25 benchmarks. There were a few benchmarks that we couldn't get subgroup values for, broken out by key demographic groups that we looked at in the study. And what you can see is in the probability-based panels, there are certain groups where it's worse, right? Young people are worse. High school RLS are worse. Black and Hispanic respondents are worse than for non-Hispanic white respondents. But the differences are not enormous, and they're sort of very in line with kind of what we expect. In the opt-in samples, right, we see huge differences here, right? So 11 points of error on average among adults ages 18 to 29, right? And about the same on Hispanic adults. And this was much larger than I think anything we were expecting. The other thing, this is an average, right? So if with a lower bound of 0. So if it's 11, right, that means that includes some really, really large errors on some of those numbers. So what's going on here? This was weird. So we noticed that the receipt of government benefits, so there are a few different variables looking at this, were some of the worst ones for the opt-ins. These had the largest error. So 4 of them here, receipt of food stamps, Social Security, unemployment compensation, and workers' compensation. The benchmarks all come from the same current population survey March supplement. And so that let us see, we could see not just how people were answering these on what each of these measures individually. We could look at who was reporting receiving multiple of the same benefits, right? And actually, let me just go back one slide. The other one I want to call your attention to is on the right, the workers' compensation, right? So these gray bars are the benchmark. The sort of the lighter shade is sort of the error above it, right? Almost nobody gets workers' compensation, right? But we see these particularly large errors on that in the opt-in samples. So when we look at people who say they're receiving more than one of these benefits at the same time, you can sort of ignore the left 2 panels here, right? So this is the share, the gray bar is the CPS number for the share of adults who receive 0 benefits 1 to 2 of these benefits or 3 or 4 of these benefits, right? And when you look at the 3 or 4, this is among all adults, 0.1% in the CPS receive all 4 of these benefits, virtually nobody, right? And on the probability-based panels, we see very, very few people are also self-reporting into that category. In the opt-in samples, though, the percentages are much larger, right? And that raises questions about, are we just overrepresenting these extremely weird people in large ways, or is something else going on? So here's the same chart if we look at the CPS estimates for people who are under 30. And again, if you look at that rightmost box, right, a fraction of a percent of 18 to 29-year-olds in the CPS get 3 or 4 benefits, right? But the percentage of opt-in respondents reporting 3 or 4 is between 17 and 21%. So it seems implausible that this minuscule fraction of the general public, in the population, is overrepresented in opt-in samples by 20 percentage points among young people. And we look at the same thing for Hispanic adults, and it's the same phenomenon, right? Virtually nobody in the benchmark in this category, but way overstating the share who are in this group in the opt-in samples, right? And that is not overrepresentation of unusual people, right? That is misreporting leading to large overestimates of rare characteristics. And so in fact, in our study, we actually asked a whole bunch of yes/no questions, right? There were 16 in total that were asked to the full sample and that weren't used in weighting. And if answering yes to a large number of these sort of yes/no questions, if you think about the combinatorics of it all, you get into these just vanishingly small categories that just do not exist in reality, right? So when we look at the share who answered yes to 10 of 16 questions, right, there's virtually nobody who should be able to truthfully be in the yes category for 10 of these. And what we see here, again, is that 18 to 29, 15% of opt-in respondents on average said yes to at least 10 of these questions, which is just entirely error, right? It's lower for 30 to 64. And what's interesting is that for 65 plus, there's virtually no error here, which is interesting, right? And we see the similar thing among Hispanic opt-in respondents, at the very bottom there, with 19% of Hispanic respondents reporting yes to these questions. And so none of this is showing up in the probability-based data. So what's going on here? So this is related to what we have been calling, bogus respondents and opt-in samples. And when I say bogus respondents, to me, this includes bots. This includes people who are being inattentive. This includes scammers. From the end user perspective, these are all functionally the same. They may require different solutions, but I'll let somebody else solve those problems. That's not me. Couple of important things. So these are people who are not answering questions truthfully. And what we're seeing is that they are disproportionately concentrated in these particular demographic subgroups, particularly 18 to 29-year-olds and Hispanic adults. And the result, right, is since the bad data is concentrated in these groups, you get these huge errors within subgroups that don't show up as much on the general population estimates. And the other thing is that this is measurement error. This is not something you can just weight your way out of, right? So I kind of resent that I'm going to have to go learn factor analysis and item response theory now after spending so much time on this selection stuff. But what's important is that this does not manifest in probability-based samples. We just don't see this kind of behavior. And I think that, that sort of obvious why that might be, right? People cannot select in. In almost all of the opt-in panels that are used for public opinion research, there's some sort of monetary reward people are trying to get. And we use incentives in probability-based surveys, right? But you don't get to sort of go in and repeatedly try to claim it, well, I don't know, Nick said maybe they actually do, but it's on a much smaller scale. What people are doing is, you go to a website where you can sign up to take surveys to get gems in your mobile video game or coins, or to get, gift cards. And you can just go through and, try to take those as many times with as little effort as possible. We did a follow-up study again in 2022 because there is an extremely generous interpretation of what went on, which is just that, yes, we are overrepresenting these crazy people. And so we did another study where we asked, are you licensed to operate a class SSGN submarine? So for those who don't know, that is a nuclear submarine operated by the US Navy. There are 4 in operation that I last checked. And the number of people who are licensed to operate one of these things is effectively 0. On the other hand, there are a nearly infinite number of people on the internet who will tell you that actually it's an Ohio-class submarine. The SSGN is a Navy designation that differentiates it from the SSBN, which carries ballistic missiles instead of guided missiles. So I learned that, and we'll be a little more careful next time in the classifications. So in any event, nobody's saying yes to this question. Almost nobody's saying yes to this question is being honest. And what do we see? We see exactly the same error pattern, right? 12% of adults ages 18 to 29 say they are licensed to operate a class SSGN submarine, and the percentage among Hispanic respondents was 24%. Somebody on Blue Sky asked if I had considered the possibility that the Navy was lying to us about the number of submarines and submariners as a possible explanation. And just to be frank, I did not consider that as a possible explanation, but future research is needed. So there's a really key point, actually, that I felt like I put it very well, actually, when people asked about this online. And so I just thought I'd paste this in here. We do not think that these are actual 18 to 39 or 18 to 29-year-olds or Hispanic people responding this way, right? This is people who give bad data on the substantive questions are also giving bad data on their demographics, right? So it's easy to sort of not realize this, even though it sort of is intuitive after the fact. But I think that's a really key point, right? These are people giving bad data on a whole lot of dimensions. And it's a large share of people in these groups on the opt-in panels. And so the question is, is this all just academic? So I had a conversation with Mario Calagaro a couple of weeks ago, who many of you may know, and he had been talking to a bunch of people who have to make decisions about funding big surveys. And he had been showing them our data from our benchmarking study, and he'd said, when they see these like average errors of 6 percentage points, like that doesn't seem that bad. It's hard to make the case that that this is really a big deal. And again, the point about the averages and the lower zero bound and huge outliers, but it's true. But so there's not. We don't see how these sort of findings about the accuracy of polling or polling data in these kinds of benchmarking studies, what the implications are for that sort of the information ecosystem out in the wild, which gets to the study that we just released on Tuesday that a few people have referenced, right, where we set out to replicate a particularly alarming finding that popped up in December. And that was in response to this headline here in The Economist, right? 1 in 5 young Americans thinks the Holocaust is a myth. So that would be really bad if it were true. And I had just, we'd been working on this, and my immediate reaction to this was, that really looks a lot like what would happen if in fact very few people believe this, right? but you've got a lot of opt-in respondents who are giving bad data, right? And so this was the Economist YouGov poll. It is an opt-in sample. And, you know, we thought this can't possibly be right. So we decided to replicate this on our panel. And part of the reason there also is that it's not just as sort of an alarming finding, it's got huge pickup, you know, in media all over the world. This is just a smattering of the headlines here. This is actually a billboard in New York that someone sent us a picture of where this had showed up. So this is a genuinely, I would say, harmful finding, not just to people who are, you know, threatened by anti-Semitism, but also, you know, it sort of mischaracterizes an entire generation of people in a very negative light. And it's just all over the place. So we replicated it. And what did we find? So we could not replicate the finding, right? So this is, you know, the share who said they agree with the statement, the Holocaust is a myth. On, you know, on the opt-in sample, it had been 20%. On the American Trends panel, it was 3%, and it was 3% for all of the age groups, right? There was no age difference in the probability-based data, right? And so, you know, again, you could try to make the very charitable explanation that the panels are sort of overrepresenting the extreme right of the you know, young Americans, but it's just, it's clear to me that this is all just bad data. You know, the other thing is there were other questions, and to their credit, they released all the crosstabs. You know, they also had included a question about attitudes on abortion, and what share of adults who think abortion should be illegal or legal in various circumstances. So we replicated that too. And in the original study, you can see, so 48%, they reported 48% of Americans, young Americans, thinking that abortion should be illegal or legal only in special circumstances, such as the death of a life of the mother, which is just wildly disconnected from any kind of research that people have done, right? So when we replicated this, we got 23% of people in that age group espousing that, which is in fact about what you find on other, you know, rigorous probability-based surveys. So, so I think the point there, right, is this is sort of one particularly dramatic result that sort of filtered into the ecosystem. You know, I wouldn't have seen it, but for the fact that, you know, that it did get such high profile coverage. But all kinds of estimates have these problems, and they're sort of being reported on, you know, not entirely at face value, but I think it's easy for people to think that like these, you know, weighting methods, and that we've sort of solved these issues, especially when you think about the prevalence of the methods in terms of what gets reported on. You know, there is real risk to sort of relying on some of this stuff at face value. So I'm going to sort of wrap up here and ramble about a few kind of big themes that I think are key, you know, and thinking back to the early debates, you know, and sort of the APOR versus Andrew Gelman kind of argument that, you know, that was happening 10 years ago. So, you know, one of these themes is a question of design-based versus model-based inference, right? And I think this is sort of where I think Andrew Gelman was coming from at the time, right? So his point was that randomization is not giving you your inferential validity when you've got 96% non-response, right? And that there are very well-developed theoretical methods for doing model-based inference in the absence of a random sample. And that is all very true. Same time, you know, I think the APOR statement that, you know, there is not theoretical grounding for a lot of these methods holds up, right? For a probability-based sample, even with non-response, there's a very clear picture of where you get to the population, where different kinds of people drop out, and you can rationalize about why that's happening. In the opt-in space, it's unbelievably complex. And I'm not sure even the people who are sort of doing it can fully explain how one person winds up in a sample instead of somebody else. You know, the sort of routers and markets for sample are incredibly complicated. So, you know, we're not doing, now the debate is, in this respect, is sort of over. We are not doing design-based inference, right? Like, we're just not. The randomization is not doing that for us. We are using models, and I think we sort of acknowledge that in the APOR task force report. But what the randomization does, what probability sampling does, is it puts some bounds on the scope of possible things that could be going wrong, right? And recruiting offline ensures that people, you know, sort of bad actors aren't able to sort of inject themselves into our samples, right? Like, we do still have measurement error and satisficing. These are all problems, right? But we have more visibility into what's going on. So I think in this sense, right, the debate about design versus model-based inference is basically settled. And the model-based side is won, and we sort of, and that's probably good, because I think we needed to acknowledge that. And there was a bit of an emperor has no clothes vibe to a lot of the sort of most strident folks in the debate early on. You know, another key point, and this has come up during the conference, is the question of representation versus measurement error. You know, I've almost entirely focused, all of my work has been on representation error, and I think that's true for most of the research looking at probability and non-probability samples. What we're seeing here in our last study, I fully went into that expecting that to still be the case, and it was not. And I think what we are starting to see, though, is that, in fact, the measurement error side of things is key. And that, you know, measurement and respondent behaviors, I think, you know, sort of as a field, we've kind of assumed that for the most part, when somebody gets into the sample, that they're behaving in more or less the same ways in the probability and non-probability samples. And that's just not the case, you know. And we've done other work where we found that things like, you know, attention checks and whatnot, the people get past it. You know, the people who are trying to get, you know, whatever the reward is, know what's likely to screen them out. You know, there are a lot of things that can be going on. So I was great, actually, to see so much emphasis at this talk on this whole measurement question, and to see that that's, you know, there's growing recognition of that issue there. You know, a lot of this, I think, comes from what we've seen as kind of a commodification of research participants, right? Which is, this is kind of an inexorable process that's happening, you know, that's being driven by, you know, shrinking budgets, research budgets, you know, grant availability, and the need to be able to do inexpensive research. And I don't have a solution to this, but I think this is the kind of thing that we as a field need to be really thinking about, you know, when it comes to data quality. And then there are communications challenges, right? Like, you know, you know, we've got all this research. There's tons of studies that are showing these kinds of findings, you know. What do we as a field need to do to, you know, further improve the awareness of the people who are going to be out sort of reporting on this stuff in the media or making decisions on the basis of this? You know, I will say that our recent piece from Tuesday, where we tried to replicate the December Economist headline, seems to have sort of cut through and you know, it's gotten a lot more attention and visibility than any of our other kinds of methods reports that we release, right? And you know, we need to work on ways of sort of making this tangible and real to the kinds of people who need to be acting on the information that comes out of our studies. And then the last question, because I can't go this whole talk without mentioning this, is like, what about election polls, right? So it sucks, but like the whole field is judged on the basis of election polls, like, and it's maddening. And I actually went through all of the 538 election polls, categorized things into probability, non-probability, tried to look to see if there were any differences like this emerging. And it's uncanny that there are not in the election poll data. I used to work in that space. I have been a skeptic of herding, but looking at the data makes me rethink that. It's just, there's actually less variability by some of these things than there should be some, and there's just nothing. So there's not to date an empirical suggestion that this is biasing kind of top line estimates of the horse race. But there's not really any guarantee that it's not going to, or that that's not going to show up. If as you're, if you're upweighting people in these groups like 18 to 29-year-olds or Hispanics, you may be upweighting a lot of error. The thing I actually really worry about is when people go to try to explain why the election turned out the way it did, you run the risk of getting narratives about things like, well, young people did X, Y, Z, and in fact, the Hispanic population has changed in this, that, and the other way. And it may be that a lot of those kinds of postmortem explanations are just going to be based on really bad data. So again, I think this is just another thing to be paying attention to. And maybe that'll be an opportunity to do additional, education to the media or whoever, makes these kinds of decisions. But I do see that as a very real risk going forward. So those were my sort of big picture themes, and I'll leave it at that. Thank you everybody for attending, and for the organizers for setting this whole thing up. And I have no idea how long I spent, so hopefully we have some time for discussion.